So that was the introduction part. So we can now continue with the chain rule. So this chain rule is majorly used when we are doing like function which has powers. So they are like two functions in one. So we are saying, so you can read that. So this one we can easily expand. Okay, so the one on the right hand is the expansion of x to power x plus 4 squared, which gives us x to power 2 plus 8x plus 16. So because we can easily expand this, we can as well use the previous knowledge to get the derivative of that function. So here we are saying if we differentiate that, the x squared is going to be 2x, then the 8x is going to remain as 8. So here it would be quite simple to do the differentiation. You can read the next statement there. Yes. So because here we cannot expand, okay, so this would be okay. It is possible to expand it, but it would take time, and you always know we are always chasing time. So here that is where the chain rule comes in. Okay, so here what we do, we let this function here to be we let this function to be like y, okay, the whole of it, and then we suppose y is a function of u, and then the one inside the brackets we let it to be what? To be u. So with the chain rule we say dy dx, okay, this is a partial derivative, smaller change in y over smaller change in x is equal to smaller change in y over smaller change in u times the change in u over change in x. So when these smaller changes are very small, so this change in y over change in x tends to dy dx. Change in u over change in y over change in u tends to dy du, and likewise change in u change in x tends to dy du. So then we come up with this formula that dy dx is equal to dy du times du dx. So you can see that if we tried to cancel this one, we remain still with the dy what? Dy dx. So this formula does not change the meaning, only that after introducing the another function u, then we also need to cater for it here. So we are saying this result is known as the chain rule. So now get some examples here. So our first one, we are going to differentiate 3x plus 2 to power 4. So what would be our first step? Yes. Okay, so it means for you had already done this. Yes. Okay, when we are still in the beginning processes, we are going to just do this for those who haven't attended. We let the whole of this function here to be u, to be y. So y is going to be equal to 3x plus 2 to power 4. And then the one inside brackets, we let it to be a u. So u is equal to 3x plus 2. So we are going to begin by considering the u. So u is that. And then after that, we find the du dx. So on finding du dx, we are going to have this becoming a 3 because it has a power 1 here. So when we pre-multiply and subtract, we shall remain with only 3. And then now our y, which is 3x plus 2 to power 4, is going to now change, since this inside part is now u. So our y is going to be u to power 4. So we also differentiate it. So dy du is going to be 4u to power 3. Then after that, we apply the chain rule, which says dy dx is equal to dy du times du dx. So dy du is 4u to power 3, and then du dx is 3. So when we multiply, that will give us 12u to power 3. Then we just substitute back the value of u. So which would be the same as saying that this is going to be equal to 4 times the derivative of the inside one, so which would be 3. Then we reduce the power by 1, which would be 3. So still this would give us 12 into 3x plus 2 to power 3. So they would give us the same what? The same answer. So we are going to still differentiate this. So we begin by letting the y to be equal to x squared plus 3x to power 7, and then u is equal to the one inside the brackets, which is x squared plus 3x. So we can begin by differentiating this. So we shall find the du dx. So the du dx, so this 2 will come here, so that will become 2x, and then this reduces to 1. So du dx will be 2x plus 3. Then now our y is equal to u to power 7. So what is dy du? u to power 6, and still we apply our chain rule. So we shall have 7u to power 6 times 2x plus 3, which was du dx. So we shall have an answer here. So when we multiply, when we substitute for the u, we shall have 7 into x squared plus 3x bracket to power 6, then multiply it by 2x plus 3. So that would be the derivative.